All right, Sim Savages, let's attack these problems from class. So we got 8 problems here. I paired them up in the way that you would have done them in class, whichever ones you were assigned. So I'm just going to go through all of them. We'll see how long it takes. I balanced these before, but I don't have an answer key in front of me. So I'm just going to walk through what I would do to balance these. And hopefully there can be some good takeaways for you guys on this stuff. Let's go with that color. All right, so first one. Let's just do it the basic way. All right, let's list our atoms. So we have potassium, chlorine, oxygen. And since nothing appears out of nowhere, law of conservation of mass, blah, blah, blah. We're gonna have the same stuff on this side. So we have potassium, chlorine, and oxygen. Okay, so we count our atoms. We have 1 chlorine here, one potassium here, 1 chlorine here, and 3 oxygens. Over here, again, 1 potassium, 1 chlorine, but here we have 2 oxygens. So as you probably have realized by now, it's a common thing to see 2 and 3 on opposite sides. Like I've said before, a good thing to do is try and get them to 6. So let's start over here. Let's throw a 2 out here. So I put a 2 here, it's going to affect everything in there. My potassium becomes 2, my chlorine becomes 2, and my oxygen becomes 6. Okay, now we come over here. I'm going to put a 3 here to balance my oxygen. So now I have 6 oxygens on both sides. I have 1 chlorine and 1 chlorine on my product side versus 2 of each on my reactant side. So I'm just going to change this to a 2. Now I have 2 and 2. Okay, so now you go back through and check. So over here I have 2 potassiums. Over here I have 2 potassiums. Good. 2 chlorines, 2 chlorines. Okay, that lines up. 2 times 3, 6 oxygens. 3 times 2, 6 oxygens. And that is balanced. Okay, awesome. Let's go to number 5. All right, so now we got a word problem. I guess that's what you could call it. So what do I have here? I have nitrogen combines with, so let me have a plus sign, hydrogen, okay, to form, let's tell me this is my arrow, this is separating my reactants from my products, nitrogen trihydride, okay? So the tri and the ide are telling me this is a covalent compound. All right, if you need a reminder on naming covalents and ionics, go back to last section and make sure you've mastered that skill because it's going to keep coming up all year long. Okay, so let's write this out. I have nitrogen plus hydrogen combining to form nitrogen trihydride. It's telling me I have hydrogen 3 times, aka ammonia. Ammonia, not to be confused with ammonium, which has an extra hydrogen atom and is a polyatomic, but this is ammonia. Now, hopefully something looks wrong to you. I'm dealing with nitrogen and hydrogen, both of which are in Hofbrinkel and are diatomic, so I need to put 2's as subscripts on both of those. Okay, so now I have my skeleton equation written out. Let's go through it. NH, 2, 2, 1, 3. Okay, again, I got my 2 and 3 thing going on. So I'm just going to make this hydrogen over here 6 first, which also makes this nitrogen 2. This hydrogen is now 6. I come over here, I need 6 hydrogens, so I throw a 3 right here. Now I have 6. And my nitrogen is already diatomic over here, so I have 2. So to review, I have 2 nitrogens, 3 times 2, 6 hydrogens. Okay, I should go one by one, sorry. So 2 nitrogens, 3 times 2, 6 hydrogens, 2 times 3, 6 hydrogens, and that is balanced as well. Okay, let's keep going. All right, I got a bigger one going on here. Let's see what I got. Well, first of all, it is a double displacement reaction. I can see that because I start with 2 pairs of things and then the cation swap. So it's double date that went south or north, I guess, for both of them if they got what they wanted. Anyway, so let's break down our atoms. I have aluminum, bromine, potassium, and then now I have sulfate. So let me look at this. I have sulfate here, and then on the other side, I have sulfate. It's stuck together. Yes, there's a new subscript that's going to change the total amount, but that happens on atoms all the time. It stays together as a unit, so I can count it as a single unit on both sides. It's a diatomic that stays the same on both sides, so I'm going to count it as a single unit. So I'm gonna come over here, I'm gonna put the same atoms in the same order, and I'm gonna keep sulfate as a unit. Okay, so let's look. Again, there's really no right or wrong place to start with these. Well, I guess I'm getting a little ahead of myself. I need to count my atoms first. I have 1 aluminum. I have 3 bromines, 2 potassiums, and on this side I have 1 unit of sulfate. Over here I have 2 aluminums, 1 bromine, 1 potassium, and here I have 3 units of sulfate. Okay, so I can start anywhere I want. Let's start with aluminum. I'm just going to go down the line so you can see the order I'm going in a little simply. Okay, so I have 2 aluminums on my product side, 1 on my reactant side, so I'm going to make it 2 on my reactant side. Okay, now by doing that, I also affect my bromine, so now I have 2 times 3 bromines, I have 6 bromines. All right, now over here, I have 1 bromine right now, so I'm going to make my potassium bromide, this whole molecule, I'm going to get 6 of them. Okay, so now this bromine is 6, this potassium is 6. Okay, so now if my potassium on my product side is 6, and I'll go over on my reactant side, it's 2. I'm going to make it 6 over here, so I'm going to put it 3. Now this is 6, and I've just affected my sulfate. Now I have 3 sulfates. Okay, and that's convenient because that works out on my side. So this was a pretty clean balance. I didn't have to go back and change anything. I believe it's balanced. Let's go through and check. On this side, I have 2 aluminums. On this side, I have 2 aluminums. I have 2 times 3, 6 bromines. I have 6 bromines on this side, so those are all balanced. On this side, I have 3 times 2, 6 potassiums, and on this side, I have 6 potassiums, and I have 3 sulfates, and on this side, I have 3 sulfates, okay? So that's balanced. All right, great. Let's go on to number 6. Sodium chloride and fluorine react to produce sodium fluoride and chlorine. So I have sodium chloride, table salt, and ionic compound. And fluorine alone react to produce, react, the word react, and the phrase react to produce tell me it's my arrow. By the way, this and tells me it's a plus. Sodium fluoride, another ionic compound, and chlorine as a single atom. And my and is a plus sign. So sodium is a +1 charge, chlorine's a -1 charge, so I know that this is NaCl, which you should know by now. We deal with it all the time. But the charge is balanced, so I get a 1-to-1 ratio, naming ionics, knowing the formula for ionics. I have NaCl, and I have fluorine, Hofbrinkel. This is the F in Hofbrinkel, so it's going to be a diatomic. React to produce sodium fluoride. Okay, fluorine is also a halogen. It also has a -1 charge. Sodium still has a +1 charge. So that's also going to come together in a 1-to-1 ratio. So I get sodium fluoride and chlorine, Hofbrinkel. This is the Cl in Hofbrinkel. So this is also a diatomic. Okay, so I have my my skeleton equation. If you were confused at all by me figuring out the ratio or the number of atoms for sodium chloride and sodium fluoride, review your ionic formulas, getting ionic formulas from the names or naming ionic formulas, knowing which ion forms what and how to balance them, the cation and anion, because as you can see, the stuff we learn is going to keep coming up over and over again. Anyway, let's break this down. I have sodium, chlorine, fluorine, sodium, chlorine, fluorine. On this side, I have 1 sodium, 1 chlorine, 2 fluorines. On this side, I have 1 sodium, 2 chlorines, 1 fluorine. All right? So my sodiums right now are balanced. My chlorines are not. My fluorines are not. So let's start. We'll skip sodium since it's balanced right now. We'll go to chlorine. I need 2 chlorines. I have 2 chlorines on my product side. I need 2 on my reactant side, so I'm going to change this to 2. Now that also changes my sodium to 2, but now my chlorines are balanced. Let's look at fluorine. I have 2 fluorines as a diatomic on my product side, and I have 1 on my reactant side. So I'm going to change this to 2. This makes my fluorine 2, and coincidentally makes my sodium 2, which works out because now I have 2 sodiums on both sides. Chlorines are balanced, fluorines are balanced. So I have 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines, 2 fluorines, 2 fluorines. Okay, so this is balanced as well. Let's go on to the This is just number 3. Oh, that's right. I changed the order around. All right. So here I have, let's look at real quick. This is a single replacement reaction. Number 6 was a single replacement. Started me and my friend meeting a girl, and then she chose me over my friend. So I was chlorine in this situation. Now I'm all alone. Okay, single replacement. Silver oxide becoming silver and oxygen. This is a decomposition reaction because I have 2 things that were bonded together, breaking apart into their individual parts. I have silver and oxygen, silver and oxygen. Okay, on this side I have 2 silvers and 1 oxygen. On this side I have 1 silver and the diatomic 2 oxygens. Okay, so I'm going to put a 2 right here because I have 2 silvers on my reactant side. Now I have 2 on my product side. Okay, but I need to get 2 oxygens over here, so I'm going to put a 2 here. Now I have 2 oxygens on this side, 2 oxygens on this side, but I also just changed my silvers. So now I have 4 silver on this side, so I need to go back. I need to change this to 4. So now I have 4 silvers, okay? 2 times 2, 4 silver, 2 oxygens, 2 oxygens, and 2 oxygens. Okay, so that was quick. Now those are balanced. But wait, oh, okay, here's a live action relook. No, that's right. Yeah, okay, because this is a 1. I was just thinking, to let you into my mind a little bit, I looked at that and I said, well, if I divide both by 4, couldn't I put just a 1 there and a 2? Couldn't I put a 1 here and a 2 here? But that wouldn't work because I would have 2 silver. That's what I did initially, right? Is I put a 2 and it still wasn't balanced because my oxygens weren't balanced. I was thinking to simplify it, but you have to remember there's a 1 here. So if you divided everything by 2, you would get a half, and you can't have a half of a atom. Khan Academy has some good videos on this, by the way. I think I said that in most of my classes. He gets decimals, like he would put 1/2 somewhere and then multiply everything to get a whole number. I never really liked that method that much, but for some people it makes more sense. It's simpler, and sometimes it's quicker. So you could take a look at his videos if you want. The production value is nowhere near the same, or the humor is just not on point like here on Sim Science. But if that's what you like. Okay, so now number 7. We have lead 2 hydroxide. Now, some of you were forgetting your naming methods. This 2 here tells me the value of the positive charge on lead. Hydroxide is a polyatomic. So I have lead with a +2 charge, and I have hydroxide, which is OH, and that has a -1 charge. That's just what hydroxide is. And hydrogen monochloride. Okay, so this is going to be naming a covalent molecule. Monochloride. Okay, you're going to have to know that. Combined to form, here's my reaction arrow, water. Okay, you should all know the formula for water. And lead 2, again, we have the lead 2 +2. Chloride, chlorine's a halogen in the 7th group, so it's going to gain 1 electron to get an octet, so it's going to be chlorine -1. All right, so let's write it out. I have lead 2 hydroxide. Okay, so I need to crisscross, or I need to balance my charges. I need 2 hydroxides. So I need 2 of these units. Each one is negative. OH together is -1, so 2 OHs is -2. I need 2 hydroxides. That means the subscript goes outside of parentheses on the hydroxide. And then this is balanced. Okay, and hydrogen monochloride. So I have hydrogen. Mono means 1, chloride, so that's just HCl. Okay, that's an acid. We'll get into that soon enough. All right, combined to form water, H2O, and lead chloride. Okay, so again, I have a +2 charge on my cation, which is still lead 2, and I have a -1 charge on my anion, which is chloride. So I need 2 of these. Crisscross. Crisscross. I need 2 negative charges to balance out the 2 positive charges. Okay, now one thing I want you to notice about this is I have a polyatomic on this side. I have hydroxide on this side. I cannot treat this as a single unit when I'm balancing, when I'm writing out my my atoms. Okay, so I need to break this into OH and chlorine. Okay, because it's not does not exist as OH alone on this side. Okay, it changed. Now I have H2O on this side. So we're gonna write out. We're gonna write out our atoms here. Again, lead, oxygen, hydrogen, chlorine. Now another thing some of you struggled with is if I have an atom that appears in multiple places, as I do here on my reactant side, so we'll get to that in a second. Lead, I have 1, okay? Oxygen, there's 2 hydroxides, so 2 OHs, so I have oxygen twice. Now hydrogen, I have 2 hydrogens here because I have 2 hydroxides, but I also have a hydrogen here. So when you're balancing an equation, if you have something that appears multiple times on one side, you're writing the total number of those atoms. So this is going to be 3. This is 3, and I have 1 chlorine. Okay, over here, lead, I have 1 lead, I have 1 oxygen, I have 2 hydrogens, and I have 2 chlorines. Okay, so again, when you're balancing, if you have something appear twice on, I'm sorry, I shouldn't have erased that too. If you have something appear twice on one side, you get the total, or more than twice. You get the total number of those atoms on that side of the equation. Okay, and a lot of times it's best to leave something that appears multiple times to the end to balance it. Okay, so let's see what we got going on. Lead's already balanced, oxygen is not. Okay, I have 2 oxygens on this side and 1 on this side. So I'm gonna put a 2 out here. I know I haven't done this yet, but I'm gonna change the color of my balancing. I think it'll help make stuff a little clearer. I'm gonna put 2 out here. All right, so now I have 2 oxygens, but I also just changed my hydrogens to 4. Okay, so now my hydrogens are balanced, but I'm gonna leave hydrogen for now. Like I said, sometimes it's best to leave it till the end. Chlorine, I have 2 chlorines on this side, I have 1 on this side, so I'm gonna make this a 2. So now I have 2 chlorines here. I just increased my hydrogens as well. I added 1 more hydrogen, so now I have 4. And that actually works, because now I have 2 on both sides. Okay, and it looks like everything's balanced. Let's go over it. 1 lead, 1 lead. Oxygen, I have 2 oxygens. And here I have 2 oxygens. Hydrogens, I have 2 here, and I have 2 here, so I have 4 total. And I have 2 times 2, 4 on this side. And then chlorine, I have 2 chlorines, and I have 2 chlorines, okay? So just add a couple 2s, and everything's balanced there. All right, we're getting to the end. This is probably a really long video, but watch as much as you need to. All right, let's get to this one now. So I have hydrogen, I have chlorine. Let me actually go back to purple. What color was I doing? Was it this? Okay, I have hydrogen, chlorine, calcium, and okay, so here I have carbonate, a polyatomic, and I look over on the other side, I see carbonite with 1 less oxygen, but there's no, carbonate does not appear the same on both sides, so I have to break those atoms up into carbon and oxygen separately. Okay, so make sure you understand what I just did there. I see a polyatomic here, it's carbonate, CO3 is carbonate, but over here on this side, I don't have CO3, I have CO2, which is carbonite. So I had an oxygen go somewhere else. So I can't treat CO3 as a single polyatomic. I have to split it up into its component parts, which are carbon and oxygen. Okay, so on this side, HCl, Ca, CO. Okay, a lot of atoms in this one. On this side, for hydrogens, I have 1. For chlorines, I have 1. Calcium, I have 1. Carbon, I have 1. Oxygens, I have 3. Come over this side, I see that I have 2 hydrogens, 2 chlorines, 1 calcium, 1 carbon, and now, I have oxygen in 2 places. It's okay, I have 2 here, and I have 1 here, so I have 3 total. Okay, so let's get to balancing. Okay, start with hydrogen, because that's not balanced. I have 2 on my product side, I have 1 on my reactant side, so I'm gonna change this to 2. Okay, I'm gonna change this to 2, So now I have 2. Also changes my chlorines to 2. Now that happened to balance out my chlorines as well. Great. And that looks like it. It's always a little suspicious when it's that simple. But as long as I copy the equation correctly, I think it is that simple. I have 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines, 1 calcium, 1 calcium, 1 carbon, 1 carbon, 3 oxygens, 1, 2, 3 oxygens. Okay? So I am a little suspicious of that, but as long as I copy this correctly, it is that simple. All right, last one. So I have carbon tetrahydride. So I need to know my covalent naming system to be able to identify that. Combines with, hopefully you caught that was wrong. Combines with oxygen to produce carbon dioxide and water. Okay, so I have carbon tetrahydride. Tetra is for hydride, it's hydrogen. Combines with oxygen, which that's the O in Hofbrinkel, it's a diatomic, to produce products. Reactants produce products when they react. Carbon dioxide, carbon dioxide, 2 waters, or I'm sorry, getting ahead of myself, 2 oxygens, and H2O is water. Okay, so, I used the wrong color, that's all right, we'll just go backwards with the colors. Carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. Carbons, I have 1, hydrogens, I have 4, oxygens, diatomic, I have 2. On this side, carbons, I have 1, hydrogens, I have 2, and oxygens, I have 2 here and 1 here, so I have 3 total. Okay, so let's look at it. My carbons right now are lined up. I have 4 hydrogens on my reactant side, 2 on my product side, so I'm going to make this 4. Okay, now that's 4. I also just changed my oxygens. I added 2 more, so now this is 4. So if I slap a 2 down right here, it's going to double my oxygens, and now I have 4 on this side. So I have 1 carbon, 4 hydrogens, 2 times 2, 4 hydrogens, and I have 2 times 2, 4 oxygens, and I have 2, 3, 4 oxygens. Okay. Okay, so those are all the balancing equations from the work in class. Hopefully that ironed out any wrinkles you had with your own or any questions you had on balancing. There's the assignments that I gave you. The extra credit assignments gives you a lot of practice, will make you very good. Practice makes perfect. These take practice and skill of getting quick at them. All right, I shudder to think of how long this video is. We'll see if it can even upload, if it's too long, whatever. Thank you so much for watching. If you watched the whole thing, I am very impressed with that. I wish there was a way for me to confirm it so that you get extra credit, but you'll see the product of your hard work in your grade on the test. All right, thank you guys so much. See you soon.